Hello, guys. So we already discussed about the various sensor characteristics. So in our KTU syllabus, we are supposed to study about three sensors. So I am going to explain about the position sensor. So this type of position sensor you already studied in the first module about the optical encoder. So this is the same system or a same type of a sensor which we are using to understand the position of the various actuators used in the robotics engineering or robotics whatever maybe. So the actuator may be either it's a type of electrical actuator. Electrical actuator is nothing but a converting one type of one form of energy that is into the another form, say maybe the electrical energy into the rotary motion or a rotary kind of revolutionary whatever maybe. So the electric motor, maybe different types of electric motors may be used in the robotics in the form of like say for example it's a DC motor, a servo motor, a stepper motor. So a lot of motors or a lot of actuators which we are using in the robotics. So we are supposed to understand about the how it is rotating, whether it is rotating in a clockwise direction or a anti-clockwise direction. At the same time, we are supposed to understand about the home position of a actuator. Maybe rotary actuator, we should understand where exactly it is situated. You should understand about the home position, whether it is rotating in a clockwise direction or a anti-clockwise direction. So in this type of system, the thing you should understand about is very simple in construction. We have a system, we have a disk which is having a opaque as well as transparent area. So that is what is called the track, which I going to explain in the couple of next couple of slides. So here we have a system. This is what is called the schematic diagram of a system. We have a DC motor, DC motor which is connected to the same shaft, that is a gearing system. If the gear is rotating, so in such a way that which is connected to the higher other type of gears that convert the rotary motion that into the translatory motion, whatever it may be. So we should understand about the what is the rotation of the DC motor, whether it is rotating in a clockwise direction or in a anti-clockwise direction. So the one end of the shaft which is connected to the gearbox or a gearing system, other end which is connected to the optical encoder, optical shaft encoder. So what exactly it is doing? So it consists of a track system in the sense which is having a tracks disc. It's a circular disc which consists of a various tracks is nothing but which is it include the transparent area, transparent section as well as the opaque section. So in this system which consists of LED as well as the pulse disc or a photo diode. So if it is rotating, the LED is continuously glowing. At the same time the light when it is comes in contact with the transparent area, the LED light passes through the disc and falls on the photo diode or a photoreceptor. So in such a way that we can understand or we can produce a pulse signal. So as we know that this is a type of a unit signal or a pulse signal. So in such a way that we can understand that the system is rotating continuously, or if it is stopped also we can understand there is no such output which is coming out from the optical encoder. So next thing we are supposed to understand about the tracks. This is very important to understand whether the system is rotating in a clockwise direction or in an anti-clockwise direction. At the same time it is very important to understand the home position of the system. If you want to understand the home position of the system, all these parameters we can understand by using the track system. So this is what is called the optical disc which is having three tracks. One is A, B and Z. So Z is nothing but just to understand the home position. So as I told that the Z track, this black area is nothing but the transparent area through which the LED light emits and that falls on the photo receptor. So that is all about this area. So if the light from the light emitting diode that passes and falls on the light receiver or light receptor, so we can understand that it produces a signal like this. So we can easily understand about the home position of the system, whether it is how it is situated and all. So next one is a track, middle track. So middle track is nothing but which is represented as B, and the outer track is represented as A. So next one is we should understand one criteria about these tracks. So while we are looking into these tracks, we can what we thinking about, there is no such a difference in these tracks, but actually these two tracks which is having this is not at the same line of action. So line of action is nothing but, so if this inner track that is not in a not same as that of the middle track, and the outer track which is not again same with the middle track. So in such a situation, what we are supposed to do is there should be a small difference between the middle track and the outer track. There is a small difference, there is a small difference, there is a small offsetting. That's not a difference, it is offsetting. Say for example this is a position, but there is a small offset from this middle track, and it is situated, the outer track is situated in such a way that there is a small difference between these two tracks. One is a middle track and the outer track. So next next interesting part is, if it is rotating in a clockwise direction, as we know that the outer track A is leading and the middle track B is lagging. So this is how we can understand about how the system is working. So if the outer track which is rotating at the same time, if it is the outer track is leading, at the same time the middle track is lagging, we can understand that there is a the system which is rotating in a and clockwise direction. So next one is how to understand the system which is rotating in a counterclockwise direction or a anti-clockwise direction. So in this situation, we can understand that the middle track, B, which is rotating or which is leading, and the outer track is lagging. So this is all about the position sensor. So this is how the motion is understanding. I mean, whether the direction, whether the system is whether the motor which is rotating in a clockwise direction or an anti-clockwise direction. At the same time, we can understand the initial position or the home position of a rotary actuator. So that's all about the system. Thank you once.